In this video, we're going to introduce some of the concepts of testing. You're probably very well aware that testing software is a very important activity, and it helps us to understand something about the quality of the code that we're testing. Testing can show whether a piece of code satisfies software requirements. It can also show that the software functions as expected, but what it can't do is prove that the software is 100% satisfactory. And we'll see some examples of why that might be a little bit later. You're probably also very well aware that finding a fault earlier during development is cheaper to correct than discovering it at a later date, for example, after you've installed the software in a client's company. And so we should be very careful to use testing as early as possible so that we can reveal the faults as quickly as possible. There are different types of software testing, including functional, non-functional, black box and white box, and there are others as well. And it would be well for you just to read up a little bit about some of these various types of testing. We're going to focus on black box tests. These can be planned right from the beginning of the project. So as soon as you've got the software requirements, you can start writing your black box tests. And then we can use those tests at any point in the life cycle of the project development. For example, we could take a design and evaluate it against the entire black box test plan, just to verify that the design is planning software that will satisfy the tests. And of course, we can test the application code as well. As I mentioned earlier, complete testing is impossible. We can never test a software application to exhaustion, and therefore we can never be 100% certain that the software is bug-free. Let's just consider a very small program that will add 2 integers. There's an infinite number of integers that we could input to the program, and therefore if we were going to be 100% sure that the software works in every single case, there would be an infinite number of tests to be performed to prove that. And of course, that's just not possible to do in practice. And so we use a concept called equivalence partitioning. This is where we divide the set of all possible input values into groups of equivalent values, and then use at least one value from each group as a representative value. And if the test passes with that representative value, we can assume that the test will pass with all values from the same group. Let's take the case where we've just got to add 2 integers. Then essentially we've got one group, and that is all the possible integers, in which case we would pick 1 or 2 or a few values from the group of integers. But let's add in an extra requirement. The integers have to be positive. Now we have 2 groups because we have all the positive integers and all the negative integers. The positive integers would be considered valid values and the negative integers would be considered invalid values. And so we should test with at least one value from each of those groups. When it comes to black box testing, we would want to devise some tests based on the requirements that we have. One approach to this would be to focus on tests that cover normal values, more tests that cover invalid values. Then there are boundary values and special cases. The boundary values focus on the boundary between partitions, between valid values and invalid values. We use the special cases to list tests that are not covered by the other 3 categories. When we're focusing on the boundary values, we've got to make sure we get the boundary right. For a requirement where num must be greater than 2, then we know that anything that is greater than 2 is a valid value. So 3 is valid, and anything greater than 3 is also valid. So that is one group of equivalence. The value 2 is not greater than 2, and therefore that is the largest number that is considered invalid, and anything less than that would also be invalid, and that is a second equivalence group. And so the boundary sits between the 2 equivalence groups, that is, between the value 2 and the value 3. Or to put it another way, where we move from invalid values into valid values. And with a boundary test, what we're actually doing is putting in 2 test cases, one immediately below the boundary and one immediately above the boundary. And if we're dealing with a valid range, then there will be two boundaries, one at the bottom end of the range and one at the top end of the range, in which case we would have a set of 4 boundary test cases. Having identified the test cases, we can then start to build a test plan, which will have one or more tests, and a test will have a unique identifier so that we can easily refer to that test, a set of instructions that will tell the tester what operations to perform in the test, a list of the test cases that this test addresses, and then a description of the expected outcome. As far as possible, we want the test plan to be as small as possible and at the same time cover every single test case. But having said that, we want to make sure that invalid test cases are the only thing being tested in a given test, and likewise with special cases. So in one test in the test plan, we'll cover either a single invalid test case or a single special test case or one or more normal or boundary test cases. And that will help to keep the test small while making sure that we're not masking one error with another. When picking data values for a test, we should use numbers that are easy to work out the result. For example, 7 times 2 is much easier to work out than this calculation here. It's also a good idea to use different values for each input data item, because that will help to identify problems in the code that we're testing. One thing we shouldn't do is to assume that the tests in a plan will be run in the order in which we list them, and because of this, we should make sure that each test is independent of all other tests. This will avoid relying upon the outcome of a previous test to be the input for the current test. Here's a very small example, and you can see this fuller example by following the link in the description. Our problem description will give us some requirements, and the first step in developing a test plan is to identify those requirements. So we would write a list of requirements, and then for each one of these requirements, we would identify normal, invalid, boundary, and special cases. Not every requirement will give us cases in each of these categories, but where there are test cases in those categories, we should write them at this stage. Having developed a list of all the test cases, we can then write a test plan that is based on the test cases, and because the test cases are based on the requirements, that tells us that the test plan is focused on the requirements. So here's a partial example. We might have a couple of requirements from which we can identify some normal test cases, some invalid value test cases, some boundary test cases. And notice that we're listing the requirement that the test case addresses. And having derived the test cases, we can go back and check to make sure that we are covering every single requirement. Then we can use those test cases to generate a test plan. And for each test, which has a unique identifier, we can then write an instruction of what to do for the test, which includes identifying the input data. We also list the test cases that we are addressing, and we list what is expected in terms of the result. Now, I've only given a very brief introduction to some of the concepts of testing. There is a lot more to read about, and so I recommend that you do some additional reading on this subject.